Hello everyone, my name is Dmitry Vostokov and I introduce Victimware presentation today. This is a version 1 of the webinar. If I missed anything during preparation, I added to the version 2. At the end of my preparation, I decided to keep this presentation as simple as possible and as short as possible and add a practical example at the end. Prerequisites for this presentation are very simple. This webinar has a simple goal to introduce pattern-driven software diagnostics to malware research and analysis community. What is Victimware? Victimware is software whose execution is affected by execution behavior of other components. The latter is broad enough to include software causing unintentional problems and even software that is supposed to protect from malware. We also included malware in Victimware box on this picture because malware can also suffer the same behavioral problems as their intentional and unintentional victims. There are some parallels between victims of crimes and victims of malware. For example, the focus of public attention is usually more on criminals and malware, or crimeware as part of malware, and less on victims and victimware, despite the fact that the latter include the largest part of population and software components. There is one reference about victims in macro 6, the so-called victim thread that experienced an exception. A few words about Victimware typology. Here I borrowed the typology from Schäfer, a well-known victimologist, and modified it a little. Some types are obvious, like targeted, unrelated, or self-victimized victimware. Few words about provocative victimware. Provocative victimware is software that, due to their implementation and design flaws, attract malware writers. Precipitative victimware is software that communicates inappropriate data despite being well designed and implemented, so the focus of responsibility shifts to software users. Political victimware is victim of battles between various software vendors. Here a typical example would be various value-added components or hooksware. The approach of software victimology is to use patterns of abnormal software behavior, such as crashes, harms, spikes, leaks, patching, and so on, to discover malware. There are more than 200 software behavior patterns that can be found on Software Diagnostics Institute website. Some of them you would see during practical example at the end of this presentation. Some patterns are related to the organization of memory, and they are in the process of development. So now we come to a crash dump analysis example. and open crash dump. And the crash dump, let's see, it was this one. Okay, so there was some glitch. So we opened log file. So first of all, we fix symbols. And reloaded symbols. And then we use k command to dump stack trace. First of all, we see exception processing code, reporting exception. We also notice that this was possible heap corruption. Also, from modules, we see that execution was related to internet connection. Notice also this suspicious number on stack trace. Usually such numbers are normal for .NET because of JIT compilation. But here we don't see any .NET or common language runtime related modules. So this is clearly suspicious. So what we do, we take this address, this return address, and disassemble it backwards. It seems to be normal. So there is some call. Let's check this function. So let's see the value at this address. And disassemble the beginning of this function. Actually, if we use DPS, we would see that this is internet close handle. So let's disassemble this value. So what we see is jump at the beginning of the function. So obviously it was patched. So let's disassemble this address. We see that this seems to be normal function with prologue. Let's now determine which module is this, which component. So we list modules using lm command, but we won't find such address because we see that all known modules from the list start with high addresses. Let's also check attributes for this address. We see that this address the code belongs to read-write page, usually code only read-only or execute-only. So what we do is another command, image scan available memory for MZ signature. You know that every module starts with MZ signature, MS-DOS program. So what we notice, we see that all modules that found, they all have protection to this one. Read-write is suspicious, and also another one, like this one, 4, with the name screens, also looks suspicious. So let's check address. It's also page read-write. Shouldn't be for code. And notice that we don't have screens on the official module list. Screens DLL. So let's now double check this internals like data. So let's take this address and see if there are any strings inside. So we use search command, search for ASCII strings from this address, and we supply length, and length is this value. Or we could use db command for manual data inspection, but strings is much better. So we see that there are some interesting strings here, such as password, username, so we suspect that this module was probably trying to intercept some data, send data. Okay, there is a question, let me see. Okay, so oh yes, that was the problem was log open. Yeah, that's right. I think the problem was because I already created this log file before. So thanks. There was a suggestion from Michael. So you see that we got so many interesting strings here. And also we can check Unicode strings as well. So let's search for Unicode strings. Because usually if you use functions, Unicode version, such as create process or so on, process names and parameters are usually in Unicode. Let's see if there's anything suspicious. So I just search for .exe. So suspicious is this check NTFS function. So this, later on, this program was found as startup program, masquerading as check file system, NT file system. So what else can we do? We can also examine headers, module headers. What we see is that it doesn't have any import table. So it does everything on the fly, probably. And also, yeah, it does everything on the fly. I think that LMI command also doesn't work here. What can we do? We also check that screens module that was address this one. Screens, that screens DLL module we can see has import address table. And we can check what functions it imports just to see what type of functionality this module does. So let's dump with symbols. And the length is 58 divided by 4. So we see the function names. It imports all related with graphics, related to capturing and saving images. So obviously this module related to screen capture. And if you search, if you Google it, you find that this is well-known part of some malware packages. And also notice that sometimes embedded paths are useful as well. So this is all. Let's close. Log file. So this is all for this example. I just wanted to demonstrate some patterns that led to the discovery of malware incident analysis. So now come some references for further reading. There is one short book on criminology Criminology, the basics which covers victimology as well. The other one, handbook, has lots of useful conceptual articles related to human victimology. So it is interesting to read as well, regardless of software. And I also included links to relevant presentation and books from Software Diagnostics here that cover patterns. After this webinar, I post this presentation on the website. I'm also very interested in how to improve this introduction, so please send your comments and suggestions. If I can't answer your questions now, I then post it on Software Diagnostics Services website later this week. So if you have questions, please ask. Just a few short notice that in a few minutes, I think in 15 minutes or so, Debugging TV Frames episode starts to show Windows and Mac OS X examples for stack memory region boundaries. So if you are interested, please attend or register. So if you have any questions, please ask. Anyway, thank you for attending this webinar. There is one question in this moment. Is there some pattern listed on Software Diagnostics Institute website about finding malware incident from crash dumps? Currently no, but I'm going to provide some maps, pattern maps from behavioral patterns to malware, classes of malware later on. Usual candidates, of course, are patterns related to hooking and also abnormal modules, their attributes, and so on. Actually, one recent study, one recent pattern is directly related to malware. I think the latest one, it's called event module. So it's related to this case study. And also some other crash dumps I analyzed. For example, in one I found this. I found a module with this interesting name. So thank you very much for attending, and see you later for Debugging TV session. Bye-bye.